In this workshop, we are going to work on the mixing elbow tutorial, but this time we are going to make some changes. For example, I'm going to introduce this swelling part, and in this workshop, this is going to be the stationary, and this stationary part will make the vortices and mixing and the turbulence, and this will enhance the mixing in the later part of this geometry, and hence it will give you more heat transfer. And the main objective of this tutorial is that although we don't have any practical value of this geometry case here, but the thing is that you can use this knowledge to any case. For example, if you want to optimize the geometry, if you want to optimize the flow conditions, so you will learn exactly here that how you can manipulate the geometry in a space claim, then how to translate the geometry into meshing part, and then to fluent, and then to results. And because we are working in the workbench, so this R will be seen in the geometry, that this change will be automatically reflected in the meshing, and then subsequently to the fluent and CFD post. And also you can see here that we have made the few more changes in the geometry. The one of them is the introduction of this hemisphere here, and we will call this as a bump here. So this bump will make the turbulence, and this turbulence will energize the flow, and hence this will reduce the separation at this corner. So basically you are going to learn how to manipulate the geometry and how to optimize the geometry inside the workbench. And to just recall that thing, so we have section number 18. Here we are creating geometry for the mixing elbow and meshing. In section number 19, section number 20 is setup in the fluent, and section number 21 is section number 21 is the post processing of these results in fluent. And for the same case, we have the post processing in the CFD post. So section number 21, 22, 20, and 19 and 18. So these 5 sections, now we are going to modify these sections with a new geometry, with the same main geometry, but with the modification of adding the cellular part and the bump on the end of that elbow section. And we are going to introduce that bump at the 2 angles. One is 0 angle and second at 15 degrees. And also we have the 2 diameters for the bump, 20 millimeter and 40 millimeter. And also you will learn that if you make the geometry as a full. So in the previous case, section number 18 to 23, we have used the half model. And in this workshop, you will learn that if you make the full model, how this will affect the results. Although I can tell you right now that this will not make any difference on the results, but when we introduce these things, like especially the swirler, in that case we have the mixing of the flow and the turbulence. In that case, we cannot use the half model. So because of the number of blades are different, and we cannot make out of that geometry, so we have to use the full geometry. But you will see that if you want to use only this geometry, then this will not make any difference if whether you use the symmetry model or the full model. Alright, so I have taken the exactly same file as I given you in those workshops 18 to 23, and so I started with the medium mesh and the half model, and I simply deleted all extra things in the model. So only I kept the half model with the medium mesh, and all 4 cells geometry, meshing, fluent cells are created in this workshop. So let me show you, for example, this full model which I created from the half model, and that was done in a space claim. So the question arises, why we want to use a space claim now? Before that we use design modeler. The answer is that we can create this geometry in a space claim or design modeler, but in the design modeler it's very easy to modify the geometry or manipulate any geometry entities. So creating any geometrical feature, this will make these things very easy in the space claim instead of the design modeler. And therefore I'm using in this workshop the space claim. And also after these workshops, I will also give you one more workshop that how you can create the same geometry in a space claim, and then you can compare that how to process with the geometry in the design modeler or in the space claim. and you can see the both softwares and you can compare them, their strengths and their weaknesses. Okay, so now I'm going to start with this half model geometry. So I will right click here, and so I will just leave these models as it is, and as because I have done these all cases and solved all cases, so I will save this file, and this file will be provided to you as a downloadable material. But I want to show you that how you can create these things just on the screen in front of you. So I will right click here and click on duplicate, and after making duplicate, I'm going to rename this as the new name. For example, here I'm going to make the from half model, I'm going to make the full model. So I will call this as a, let's say, full model. So full model new, because full model 1 is already there, so I will name this as a full model something new. So I will put this name as a full model new, or you can put the name as a full model 2. And keep in mind that the geometry was done in the design model. So this time we are going to open space claim. Right click here and then click on the edit geometry in space claim. So instead of design model, this will open space claim, and working in space claim is much easier than design modeler. Alright, so we have this half model, and on this plane, symmetry plane, I'm going to create one new plane here. And after that, I'm going to make the full model by making the mirror part of this half geometry. And here we have the option for the mirroring. And first it's asking you that select the mirror plane. So this is the plane we just created here on symmetry plane. And then it will get you to select the geometry you want to mirror. So I will choose this geometry here, and make sure that you have the option enable merge mirror objects and create mirror relationship. So, and after that you can delete this plane, and now you can see that we have this geometry now as a full model. So from the half model, we simply created full model by just applying the one single command, which is the mirror. Okay, so after doing this thing, now just save this project, and okay, so now I will close this space claim, and at the same time you should be saving this project multiple times whenever you make any change in the geometry or any cell. So just save it. And second thing is that I am going to duplicate the mesh also. So duplicate and don't use the upstream data from this original cell. So say no here, and this will make this as an independent cell here. And then from there you can make the relationship between this new geometry and this new cell for the meshing. So I'm going to drop this geometry on the meshing cell here, and let's say I will also put the same name as the full model new. And now simply double click here. This will open a new geometry. That new geometry is the same geometry of the mixing elbow, but the only difference that we have the now full model instead of the half model. And now the Ansys meshing will load the geometry and also previous mesh. And once we're done with this thing, we will modify some name selections and also some meshing parameters. So I will let you know once we load the geometry, then I will let you know what I am saying here. So you can see that this symmetry plane is no more there. So I'm going to delete this plane, and also I want to make sure that every boundary is selected properly. So inlet large, inlet small, and this outlet, and we have the wall small, and also now we have the wall for this large geometry as well. So I will right click here, or you can directly select these three boundaries and right click on the screen and click on insert. So now instead of the old versions, this will make this selection here, and this contains all three faces here. Now simply right click here and click on rename, or you can also press the F2 key and put the name as the wall large, And that's all you need to do here for the name selections. And for the method to be applied, which is a page confirming like we did in the previous workshop, so simply select this whole geometry and click on apply. So this geometry is selected, this whole body is selected, and make sure that you change the selection from faces to the body. And as far as the inflation is concerned, first select the body, which is this whole body here, and then select these four faces because we want to create the prism layers on these four boundaries. And then the body sizing, we are going to select this body over here like we did previously. And for the face sizing, I'm going to use because in the previous case we applied the face sizing on these two boundaries. So this is the geometry here, and I will keep the same element size. So the only difference we will get is that the mesh size now will be double as compared to the half model. And also we have some error of the symmetry, so I will right click here and delete this symmetry condition from model. And now you can see the mesh. Right now we have a number of layers for inflation, they are 10. So let me check the number of layers for the case where we have this half model. So also I will open this half model mesh, and I want to see that the sizing on the body, on the faces, and as well as the number of layers in the inflation. Okay, first thing on the mesh, you can see the number of nodes here are the 56,000. So in the full model, this should be around 1 lakh. So let me check it. Okay, so click on the mesh and click on statics. So it's 1 lakh. So it's almost double the size of the previous mesh. So this is very obvious because the half model will contain the half nodes and full model will contain the double nodes. And here the number of inflation layers are 10, and so is the case with this full model. So now we are on the same standing here that we have the 10 layers for the inflation, and the mesh sizing is also comparable. Same sizing we applied on the both models, so there is no change in the mesh whatsoever. So now after that, the only comparison is based on the geometry changes, which is from the half model. And as far as the mesh quality is concerned, so you can see that the skewness is maximum is the 0.81884, and the average quantity is 0.1.